Welcome all. In this video, we will learn about magnetically coupled circuit. Completion students will be able to understand the concept of coupling circuit. Magnetically coupled circuit. The circuit we have considered so far may be regarded as conductively coupled because one loop affects the neighboring loop through current conduction. When two loops with or without contacts between them affect each other through the magnetic field generated by one of them, they are said to be magnetically coupled. So, self-induced EMF. Consider a coil having N turns carrying current I. Due to the current flow, the flux phi is produced in the coil. The flux is measured in Weber. The flux produced by the coil link with the coil itself. Thus, the total flux linkage of the coil will be N phi. So, if the current flowing through the coil changes, the flux produced in the coil also changes and hence flux linkage also changes. According to Faraday's law, due to the rate of change of flux linkage, there will be induced EMF in the coil. This phenomenon is called self-induction. The EMF or voltage induced in the coil due to the change of its own flux linked with it is called self-induced EMF. Induced EMF. If the flux produced by one coil links with the other coil placed sufficiently close to the first coil, then due to the change in the flux produced by first coil, there is induced EMF in second coil. Such induced EMF in the second coil is called mutually induced EMF. And consider two coils which are placed very close to each other. Let coil 1 has N1 turns while coil 2 has N2 turns. The current flowing through the coil 1 is I1. Due to the current, the flux produced in coil 1 is phi1. The part of this flux links with coil 2. This flux is called mutual flux. It is denoted by phi21 as it is a part of the flux phi1 linking with coil 2. When current through coil 1 changes, the flux produced in coil 1, that is phi 1 changes. Thus, flux associated with coil 2, that is phi 21 changes. So, according to the Faraday's law, there will be induced EMF in coil 2. The two coils which are magnetically coupled are said to have mutual inductance of 1 Henry when a current of 1 ampere flowing through one coil produces a flux linkage of 1 Weber turn in the other coil. Two coils which are magnetically coupled are said to have mutual inductance of 1 Henry when a current changing uniformly at the rate of 1 ampere per second in one coil induces an EMF of 1 volt in the other coil. Let us consider two coils having self-inductance L1 and L2 placed close to each other as shown in the diagram, and the coils shown in the figure are magnetically coupled but act as separate circuit. Due to current I1, the flux produced is phi1. This flux links with the coil 1 and coil 2. Similarly, due to current I2, the flux produced is phi2. This flux links with coil 2 as well as coil 1. So, in each coil, there will be self-induced EMF as well as mutually induced EMF. Coupling or magnetically coupled coupling coefficient. Consider two coils have self-inductance L1 and L2 placed very close to each other. Let the number of turns of the two coils be N1 and N2 respectively. Let coil 1 carries current I1 and coil 2 carries current I2. Due to current I1, the flux produced is phi1 which links with both the coil. Then from the previous knowledge, mutual inductance between two coils can be written as M is equal to N1 phi21 by I1